So, hi students. I hope you guys have a wonderful spring break. And as Troy mentioned on one of the first videos, on the introduction video, and then on the stream assessment videos, one of the components of this lab is basically to calculate the Hawaiʻi stream index of biological integrity. And basically, to be able to do that, we're going to use the Hawaiʻi Stream Index biological integrity worksheet provided on Laulima. That is basically a rating of 11 metrics based on the stream biological survey data that was provided by Query. And then we're also going to calculate the final score and assess it based on the ratings. Just to give you guys a little bit of a background, the regional native or non-native stream animals and number of species and number of individuals, their size distribution, and their known or suspected sensitivity to environmental conditions are biological assays of stream integrity and the ability to support stream biodiversity. So basically for this Hawaiʻi Stream Index of biological integrity metrics, some of the metrics include number and proportion of native versus non-native species, ecological niche, strata species and amphibiodromous species that are those that travel from stream to the ocean and back over their life cycle, reproductive status based on the size, and sensitivity to poor environmental conditions. All of them, these are indicators of the status of native biodiversity, demographic of native population, and the ability of the stream to support sensitive species. So basically, you guys going to the Laulima, as Travis mentioned, on the week 12, you have a different components. It's important to mention that make sure that if you're in the Tuesday section and Thursday section, choose the appropriate document, but just for the Hawaiʻi stream in the biological diversity, you're going to use two different Excel sheets. The first one will be the on the ASIC stream 2024 that Travi explained. You're going to the Hawaiʻi HSIBI tab, and once you locate these are basically let me clean this, that it was just for demonstration. So basically what you guys going to do is, based on the my apologies for the stream biota Excel sheet that was these are all the species that you guys found on your labs sections. So as I mentioned, make sure that you choose the appropriate lab section. If you're in lab section 2, this is the list from lab section 2, and then in Manoa, this is the lab section 1. So basically, this Excel sheet has the date, lab section, the coordinates, elevation, the stream, location, origin, the method that was collected, the type of organism, the species name, common name, number of counts, the size of those species, and then any specifically notes that we basically, any important notes. So with this information, following your appropriate section, you're going to then use it for the Hawaiʻi Stream Index of biological integrity. So you're going to use both. You're going to use your stream biota Excel sheet, and then with that data, you're going to then going through this document and then guide you through to fill out the Hawaiʻi Stream Index of biological integrity in the tab in this Access Stream 2024 Excel sheet. As you can see, you have origin, if it's native or not, type of organism, species name, and the size, number of counts. That all this information, you can find it on here. That is already provided. So basically, you just have to, move one data to another, one data from an Excel sheet to another Excel sheet. And then for the specific columns that we have weighting value, CWA, the community weight average, and this 11 metric score, and the HSIBI percent and integrity class, these specific columns, you're going to fill it out based on the HSIBI worksheet document. So just to give you guys a little bit of background, the HSIBI utilize 5 ecological categories that are taxonomic richness, sensitivity, species, reproductive capacity, trophic habitat capacity, and tolerance capacity, and 11 metrics to distinguish a stream of biological condition on a scale ranging from undisturbed to severely impaired. It's a framework basically comprised of 5 integrity classes: excellent, good, fair, poor, and impaired. It's provided, which it can be used to translate a stream score into a verbal or visual portrayal of the biological condition. So the procedure for this document will be basically, as I mentioned, using the data collected from your study site, following the direction provided to this data sheet for each of the 5 ecological categories to assign a subscore 1, 3 to 5 for each metrics. Use table 1 on page 2 to identify if it's native or alien taxa. It's important to mention that you guys exclude tadpoles on soft-shell turtle from your data if applicable. And on page A, find the sum of your calculate subscore to determine your final HSIBI score as a percentage. It's important that you guys note that the lowest final score you can get is 11 or 20 or 20%, and the highest score that you can get is 50 to 100%. We're going to get more in details about that later. Table 15 on page 9 can be used to determine the integrity class of your study site based on your final score. On the second page of this document is basically a table of native and alien stream fauna with the common name, species, and origin. Thankfully, you guys already have that data provided by Corey on the Stream Biota Excel sheet. So you guys probably don't have to use this table too much. So on the third category is the taxonomic richness, and is the metric 1. You guys remember that, as I mentioned, you're going to basically have 11 metrics, as you all can see in this HSIBI tab on the Access Stream 2024 Excel sheet, and you're going to fill out each 11 matrix. So basically for this is the number of native of Amphibiodromus macrofauna, and is a metric that acts as species richness in his siblings form as a direct count of the number of native of aquatic species found in study site. It's important to mention that use either table 2A or 2B. You cannot not both to determine for metrics 1. And if your study site was either in Kaimuki High School or Manoa Palua Confluence, then use table 2B. For the second metrics, you guys going to basically quantify the percent contribution of a native taxa, and it's a form of a species reason measure, and it's equivalent to Simpson Diversity Index. Basically, to be able to calculate the percent of native taxa, you guys going to put on how many native species you have divided by the total species multiplied by 100, and then that percentage. Then you, for example, if your percentage of native taxas is between 75 to 100, then your subscore is 5, and then you put your subscore will be 5 points, and then you translate that to your metric 2 to 5 here. And then, as you all can see, you will have, once you fill out each metric, you will have a total of metric subscore here in the bottom. So it's basically pretty simple. You guys have to just go through it, through the document, read it carefully. The only one that it has a little bit complex is the metric 9, the community-wide average. Then you guys have two tables. Well, first, the community-weight average is the numerical expression that reflects the relative sensitivity of various taxa to habitat degradation and the relative of individual in each taxon in a sample. So basically, to calculate the weighting values, you guys going to look in this table, table 10A, your species. And then as you can see, based on your species collected, you're going to corroborate which species was that the common name and the weighting value. So each weighting value, each species has a weighting value. So you just guys has to basically corroborate your species and then assign them a weighting value based on these tables. And once you have all your species with the weighting value, then you calculate the community weight average. And it's basically just the total species, the number of counts of species. For example, if you collected 2 Tahitian prawn species, then you would put on the formula 2 and then multiply it by the weighting value. As you can see on the table 10A, Tahitian prawn has a weighting value of 9. So you will do that for every species that you guys collected. So basically the number of counts multiplied by the weighting value and then plus other species that you have. And then divided by the total of species. And then that result, that is 8.44. With that result, you go to table 10C and then assign a subscore. As you can see, this result was 8.44. So then once you go to the community weight average tables, 8.44 fall between the 4.1 and 9.0 interval, and it's a subsequent, then it's a subscore of 3. So then once you get that score, you go through your access stream data and then go to the, wait a second, to the community. This is the metric 9. Make sure that you guys are inputting your, once you get a subscore in each metric, make sure that you guys are putting in the appropriate metric, and then you put it here, you go, and it's a subscore of 3. You just go here, in the access stream data, and then put 3. And then these are all you were going to do again with each piece that you guys collected, the weighting value and the community average. So it will not be here, sorry, it will be in this part, this point. And then once you guys fill the weighting value of all species, the community average of all species, the metric is subscore of each metrics, then you have to get the percentage of HSIBI that is basically found in table 13 on the HSIBI worksheet. And it's basically the, you have to assign HSIBI for each metric and then determine the final HSIBI score by adding points from metric 1 to 11 and then calculate the percentage. So you do that with your final HSIBI score as a percentage, and then you put your total, as you can see in this formula, divided by 55 and then multiply it by 100. And then that total is the total of HSIBI of the 11 metrics. And the integrity class, basically, what you did is you're going to circle the integrity class of your stream using your calculate final HSIBI percentage score. So based on that percentage score that you guys calculated on the on table 3, then you determine which integrity class is, if it's excellent, good, fair, poor, and impaired. Yeah, it's a pretty basically straightforward. If you guys have any question, don't hesitate to let me know, Dr. Travis or Emma.